Sure. Welcome to our Glory Globe TV. I'm Tech News. Yeah, it looks like a magic trick. Cells at the bottom of a liquid or medium begin levitating, then hovering at a particular height with no physical contact, and invisible force directs certain cells to float up or down in unison like mini submarines. But there's no slight hand going on here. It's all taking place in a new cell sorting device that uses electromagnetic levitation to precisely direct the movement of cells, developed by Stanford medicine researchers and collaborators. And the device can be used to separate different types of cells, like cancer cells from healthy cells too, or live cells from dead cells. For example, with many potential application in the lab and in the clinic. In the clinical setting, you may have a very low volume biopsy sample and you want to look at certain cells and keep them viable for their genomic testing. That would be a perfect application for this technology, said Gozode Durham's PhD, assistant professor of radiology and senior author of a paper published in the Proceedings of the National Academy of Sciences describing the new technology. The lead author is Malobika Ramarao, a former researcher in Durham's lab. Unlike other cells sorting techniques, the new device called electro-LEV does not require attaching fluorescent levels or antibodies to cells or exposing them to Hertz chemicals or centrifugal force. Instead, cells are separated based on their density and magnetic susceptibility. We can sort them gently, Dam said. Electro-LEV builds on a simple magnetic levitation systems that Rams developed more than a decade ago. In 2015, she published a paper showing that the systems could levitate just about any type of cells. Yeah, cells can levitate because everything on Earth has some inherent magnetic properties, Trump said. The magnetic levitation systems consist of a pair of magnets, each about the size of a stick of gum and slightly stronger than ordinary refrigerator magnets, placed one on top of another, North Pole to North Pole and South Pole to South Pole. A narrow glass capillary, 1 millimeter in diameter, is sandwiched between the two magnet cells in a paramagnetic solutions flow through the capillary. That means paramagnetic solutions such as the contrast agents used to enhance MRI scans slightly amplify an external magnetic field. The magnetic forces we work with are very small, around 0.4 Tesla Durham's rod, but the beauty of our system is that we put the magnets so close to each other that the magnetic field gradient is very big. That's the trick. The magnetic field gradient is a change in magnetic field strength over distance and increases when two magnets are closer together. The greater the gradient, the more force it applies to objects in the field. In comparison, the powerful magnets in MRI machines are about 7 Tesla but are roughly 1 meter apart. Yeah, the magnetic field gradient in an MRI machine is actually smaller than what we create in our teeny machine, in which the magnets are 1 millimeter apart, Tom said, in this exclusive report.